Chapter 10.4, Inscribed Angles. If an angle is inscribed in a circle, which means that the vertex of the circle is a point that is, or the vertex of the angle is a point that is on the circle, then the measure of the inscribed angle is 1/2 the measure of the arc it intercepts. For example, if arc AB was 80 degrees, then this inscribed angle here would be 40 degrees. This is different, the inscribed angle is different than the central angle. So for example, if we have a central angle here, and we'll call that A and B, and let's, for example, say that this right here is 70 degrees, so the arc, the measure of arc AB is 70 degrees, then the central angle here would be 70 degrees. But if I brought an angle that's inscribed, this angle here would be 1/2 of 75, which is 35 degrees. In problem A, we're asked to find the measure of angle X. So we want to find the measure of this angle. The arc it intercepts is arc WZ, and that measure of that arc is 86 degrees. So the measure of angle X would be 1/2 of 86, which is 43 degrees. In problem B, this time we're given the value of the inscribed angle, and we want to find the value of the intercepted arc. The inscribed angle is 52 degrees, so the intercepted arc would be 52 times 2, which would give us 104 degrees. We want to find the measure of angle C. We know that the arc it intercepts is 94 degrees. 1/2 of 94 degrees would be 47 degrees. We want to find the measure of the arc BC. The inscribed angle is 48. We double that to get the arc, and that's 96. Next, we're going to look at two angles which cut off the same arc. So angle ABD, or angle B, cuts off the arc AD. Angle ACD also cuts off that same arc, which tells us the angles have to be equal to each other. In this problem, we want to find the measure of angle R. If I look at this and look at the arc that R intercepts, is arc TQ. If I look at angle S, the arc it intercepts is also TQ, which would make the two angles congruent to each other. Angle R would be congruent to angle S. So the measure of angle R equals the measure of angle S. R is 12x minus 13. Angle S is 9x plus 2. We're going to solve that for x. And I've got that x equals 5. We're going to plug that back into R. Which gives us the measure of angle R is 47 degrees, which is also the measure of angle S. In this one, we're asked to find the measure of angle I. The arc that I intercepts is HG. The arc that J intercepts is also HG. So we know that the measure of angle the measure of angle I equals the measure of angle J. 8x plus 9 equals 10x minus 1. got that x equals 5. Plug it back in to either equation because they're equal to each other. We have that the measure of angle I is 49 degrees. If we have if we have an angle that's inscribed in a semicircle, we know this is a semicircle because FH is a diameter. If we have an angle that is inscribed in a semicircle, then it will always be a right angle. It doesn't matter what point I choose, it will always be a right angle. And if I choose something in this other semicircle, it will also be a right angle. In this problem, I want to find the measure of angle B. Since this angle ACB, is inscribed in a semicircle, I know that angle C has to be a right angle, which leaves me with the other two angles adding up to be 90 degrees. Measure of angle A is x plus 4 plus 8x minus 4 equals 90. I'm going to solve for x. Once I have x, I have to make sure I'm plugging back into the angle I want because B is not always congruent to A. So the measure of angle B equals 8x, so 8 times 10, minus 4, which would give me 76 degrees. I'm asked to find the measure of angle D. I know that DFE is inscribed in a semicircle, so F is 90 degrees. So 2x plus 6 plus 8x plus 4 equals 90. So x equals 8. So the measure of angle D would be 2 times 8 plus 6. Which would give us 22. The last theorem in chapter 10.4 concerns quadrilaterals inscribed in a circle. You cannot assume it's a parallelogram, but what we do know is that the opposite angles are supplementary. So in this picture we know that the measure of angle L plus the measure of angle N equals 180, and that the measure of angle K plus the measure of angle M equals 180. So we're given that we have a quadrilateral inscribed in a circle here, and we're asked to find the measure of angle S and the measure of angle T. So those are the two measures that we're asked to find. We know that opposite angles are going to be supplementary. So if angle V is 90 degrees, then angle S would also have to be 90 degrees for the two of them to add up to be 180. We know that the measure of angle U and plus the measure of angle T will be 180. So 14x plus 8x plus 4. Now I'm going to solve for x. And I got that x equals 8. So now I need to find the measure of angle T. And I have the measure of angle T is 68 degrees. So we want to find the measure of angle N. We know that the measure of angle L plus the measure of angle N equals 180. So 11x plus 13, 11x plus 3x plus 12 equals 180. I'll solve for x. And then I will calculate the measure of angle N. Which gives us 48. Once again, there are additional problems. Their answers are posted online under the notes for Chapter 10.4. And that's it for this lesson.